so much, and really appreciate the opportunity to speak forth. Um, Being an avid techie, I was told to finish this in 15 minutes. It's a tough ask because there's so many facets and variations of really implementing and adopting agentic AI in any context, and of course in banks, which are very complex processes. There are quite a few variations. I'll try to give you a very sneak peek into what all it takes to adopt, an agentic AI framework and implement agentic AI in a bank's context. So what I'll cover very quickly, I'll give you a case for agentic AI, how it is contextualized, where does it play in an existing ecosystem, and then I'll try to give you some understanding, and I'm pretty sure my subsequent speakers and panels will delve much deeper into each of those areas. I'll talk about what are the complexities, what are the different elements involved in implementing this. And then finally, I'll talk about some of the choices and some watchouts. So that's what I'll hope to cover in 15 minutes. Now, quickly contextualizing, most of the banks would have had the foundational elements already in place. You have system of records, all your applications which are running the business transactions. The system of engagements, either through mobile devices, chats, etc., will be there. System of things, how do you interact? All those are in place. Reasonable amount of intelligence we see being adopted using traditional machine learning, generative AI, and various complex data platforms which could assimilate both structured and unstructured data together. So all those are in place to a reasonable extent, to varying degree depending on the type of banks, where you are, and so on. And of course, most of the banks would have also embarked on an automation for process orchestration. So RPA, which we typically used to see, robotics process automation, would have already achieved that. So essentially now, this stage is really set for decision autonomy, and that's where agentic AI comes into play. And it really would amplify the whole hog of really leveraging all the investments that would have gone into a banking process. So that's where agentic AI comes into play. How evolutionary decision making, autonomous decision making will start getting implemented, and you sweat really all the assets and all the investments in technology that banks have seen. Now there are different ways of adopting agentic AI. One could very quickly do a smart overlay, as we call it. So you do not do much of a process re-engineering. You look into whatever the processes are, whatever state they are in. You wrap an AI agent that helps you to be more efficient, achieve operational efficiency, lesser errors, etc., etc. Then there are two other phases. You either develop an agentic by design, by having simultaneously process redesign. Because when you involve agents and they are supposed to access data from various applications, legacy, non-legacy, off-the-shelf applications, the agents have to be made aware of those. And that's where at many times we face challenges and we see challenges. And that's where a bit of process redesign, a bit of modernization of apps, a bit of technical re-engineering are needed. And thereby, the increased resilience and all the other, hyper-personalization, which is context-driven, etc., can be achieved. So, these are the different steps. And unless you really have a simultaneous process overview and process redesign overview, you would not be able to really reap the maximum benefit out of an agentic frame. Now, once you do that, you need to be aware of what are the varieties of agents that are at play, and what are the patterns of those interplay of agents, and what are the role coordination. So essentially, agents work in tandem with human in the loop. And depending on the complexity of tasks that you're trying to automate, the nature of agents, the type of agents that you deploy, the formation in which you deploy, that really comes into play. So for example, I've just listed out, and later on in my subsequent slides, I'll give you some context to use cases, wherein, what kind of use cases really need what formation of deployment and what kind of agents. Because the complexity of the type of memory sharing you need, the kind of, reasoning complexities and algorithms you need in an agentic framework varies based on the nature of agents that you choose. And that actually is dependent on the type of task and the set of processes that you're trying to enable with. So you have simple reflexive agents all the way, for very static, non-evolutionary kind of tasks. And, that's an enhancement of RPA essentially. And all the way to the other continuum, other end of the spectrum of learning agents, wherein, things are evolutionary, things are changing, really dynamic. And there you really want agents to learn as it executes and over a period of time reflect on the patterns they would have encountered. And hence, that's the most complex kind of agents that work. Again, when you look into the patterns of deployment, you could have a centralized pattern of agent deployment. So you would have an agent which would centrally plan how the other sub-agents would be working in tandem, and how and where human in the loop comes into play for all the feedbacks and all the reflections. So essentially, there's a planning pattern, how they interact with existing tools, and by tools I mean applications. And later on, you will see a concept called model context protocol, which is needed for the tools to really interact with complex solutions like Gen AI and large language models. How do they interact with each other for passing on the right context of an application step, all the way to kind of how they reflect. How does a model start reorienting? How does a model start reflecting on the efficacy of the task that the model should have, that the agent should have performed? So there are variety of complexities involved in the way you deploy the patterns of agent deployment. And finally, how the coordination across agents work in a complex network. There are different ways of looking into it. There might be all agents working in tandem with similar kind of goals, balancing each other. There could be competitive agents being put into play, and there could be a hierarchical set of agents, a set of agents which are planning, and a set of agents which are then allocated tasks, very specific tasks to perform. So all these elements, actually, depending on the case that one is trying to adopt, have an influence on the architecture, on the variety, and on the way you deploy. Having said that, I just wanted to give you a quick illustration. So this is a very typical agentic kind of deployment, wherein user will have a query, some kind of prompting, and that is taken over by a planner agent, which then looks into, for the assignment, for the objective stated, how to disintegrate or decompose this set of tasks, and then individual task level agents start working on, with the help of model context protocols, interact with various tools and applications, and they pass on the relevant outputs. And there's a composing agent which takes everything back together and offers the output to a human in the loop or a decision maker. In many cases, the decisions are taken at some level at the agentic framework or the network agents level, but then the finalization, the actual decision making might need a little bit of a human interaction and interference. And that's how typically they're deployed. And I've tried to kind of give some illustrations of cases. And again, I mean, this is just an illustration. This is not an exhaustive list by any means. But this will tell you, depending on the complexity of a case, like if you look into a relationship management case wherein one needs to run a real-time portfolio optimization model behind, and then take a decision as to to derive insights for a wealth advisor. The agents would assist to do that, and you can pretty much do that kind of a thing with a model-based reflex agent, as I was telling you, which means the agent takes advantage or takes recourse to a model behind and runs it, and then kind of gives an output, all the way to very complex situations wherein there are multiple goals and objectives put in forth. For example, in a KYC onboarding case, or a customer engagement case, or a risk and fraud detection case. So there are different kinds of agents which would be at play, different levels of complexities which will come into play. I don't want to repeat all the things that are there. I hope in some form or fashion this content will reach you to give you a kind of a context as to what are the different choices and varieties and influencing attributes that drive your design of the agentic network. So now, having said that context, I just want to also dwell a little bit on the considerations and watch-outs for implementing an agentic AI, and broadly classified into three aspects. when you do this kind of an implementation, what are the internal risks and considerations one need to go through? What are the external risks and considerations as well? Because, you know, as you go on the right hand side, on the last bit, which is more around ethics, ethical considerations, those are the most complex ones to handle. Because there's too much of gray over there, and the choices and the control that you have over in your design of the framework is minimal over there, and you really need to be on a continuously monitoring basis to see the implications. So again, I mean, this will give you a context of what are the watchouts. There are common things like hallucinations. There are common things like privacy related breaches, common things like agents coming up with a decision which might not be conforming to the regulations which are in place, and we should need interventions, we should need really retraining and so on. And a reasonable amount of time needs to be spent to really fine tune those parameters. So these are some of the watchouts at a very broad level. And finally, I'd like to also start talking about what are the technical layers that goes into building an agentic network. And you have variety of technologies at play, all the way from a compute and foundational element. You have to choose what kind of a cloud provider, what kind of computational requirement, what foundational models will go into your agentic frame. How would you achieve trainings? How do you refine based on reinforcement learning models with human factors into play? And those elements, the whole foundational element, which most of the banks really understand, but then there are implications as you go up from here. Because when you look into the storage and the organization pre-processing perspective, the more complex aspects of what kind of vector DB do you need, what kind of agents and tools repository you need, and the kind of memory management, how much of that memory will be shared across variety of agents, how much will be very specific to agents, etc., etc. And then you come to the actual deployment, agents and tool management and deployment repository. So there are two aspects I want to call out. One is the orchestration framework that goes into play, and there are many choices, all the way from off-the-shelf solutions like Crew AI or a LangGraph, to semantic kernel from Microsoft and so on. So those are some of the choices, and I'm pretty sure SaaS has its own level of framework orchestration models which they would like to deploy. That's one of the choices, of course, and then you have the other traditional workflow builders which give you off-the-shelf, very quick workflow building and agentic framework deployment capabilities. Solution providers like N8N or Make, etc. They come with many pre-built repositories of workflow builders, which is very quick to adapt. All the other things that I'm talking about are all taken care of pretty much in that layer. So those are some of the aspects which one need to be cognizant about. Finally, I would like to also talk of observability, which is the more complex part of really monitoring an agentic network. And when I say observability, you have to observe all the complexities involved in an agentic network deployment. You are deploying a large language model. The observability could be done through a Helicon, or a kind of a RISE kind of a tool, or a Langsmith. So here all you are looking at is what are the different states these agents go through, how the tasks are achieved, at what point it achieved, what are the handshakes and what are the transition points, etc., etc. So you have those choices, and what we help our clients with is deriving and choosing the right set of technology, right set of tools repository, fine-tuning them, and really having the most optimal outcome given a business use case. And that's the most important element that you have to have, because there's so many choices and so many dependencies on the technology that you deploy. So this is just a very quick primer and sneak peek into the complexities. I'm pretty sure the subsequent discussions would be about each of those elements, and what are the further details around them, and you'd appreciate those in line with actual business contexts and actual use cases. So that's all I had to talk about in a very quick snapshot. And I hope you'll have a very, very fruitful further discussions on each of these elements. Thank you very much.